Oh, should I move because you...
All right, wait a few more seconds to everybody come in, so that way we don't have everybody go, what do you say? What's happening? All right. All right, good morning. Hello, Regina. Ron. Yes, you did. Chandra. Good to see you. Robert. Terry. Nicole. Good to see you, ladies and gentlemen. Cassandra. Yeah, what's the risk for Oklahoma City Metro? It's $1 million question. Phyllis wants some good news. So, Kevin's on top of it. We're going to discuss that here in a second. Jacqueline's a hot mess. So are the models. And so is the weather. Today will be a hot mess. So there you go. We're doing obviously a lunchtime live to talk about the latest data this morning. So I looked at the last couple of days, and you can pick a model and get an output that's going to vary a little bit from the other, but there's an overall consensus that we don't ignore. So, and this might be a slow connection at times. So if it pauses or if the feed messes up, just hang in there. So it may not be the best where I'm at, but bottom line is we're going to see some storms today, obviously, and those will be severe, and some of those will have some pretty decent hail with them, some large hail. You can probably get up to 3 inches or greater. So yeah, you're talking about the baseballs or so. And then we'll have some damaging wind, and yeah, there's gonna be a few tornadoes out there across Oklahoma. So the setup is our typical stuff. We have a storm system in the upper levels coming in out of the southwestern part of the U.S. It kind of comes in a little negative trough to it, not quite, but just a hair, which is kind of ideal, believe it or not, for Oklahoma. And what that does is cause a little bit of a dry line bulge out in western Oklahoma, and it sets up a nice triple point. So we have a couple of focused areas to get storms to initiate, and where the shear is going to accommodate those areas to really produce some rapid intensification. Now, as you know, there's a little bit of rain out there and there's some clouds, so that's going to help to kind of stabilize the air a little bit for this first part of the day. Now, as that diminishes and things kind of stop in that department, we'll get a little bit more heating, and the atmosphere will destabilize a little bit more. Kind of a saving grace, though, I think, is, believe it or not, anytime it usually rains, before any big event, if it rains a little too much, cools temperatures down a little too much, that helps to keep instabilities down. So there's always a trade-off, right? But with this case, it's not supposed to be that significant this time around, and the shear in the atmosphere is supposed to overcompensate any lower Cape values that we might have. So Cape value is a measure of just basically raw instability in the atmosphere. So we're going to have a lot of that around today. This is going to be kind of an old school live because I don't have my, let's call it my streaming laptop with me. I've got a little tablet. So this is this is gonna be a little bit different. This is like going back years ago. I used to start doing this just because of the situation I'm in right now. But I'm going to show you what the model day looks like and what the latest from the Storm Prediction Center, and then we're going to go from there. And I'll try to answer some of your questions at the end. So let's be a little longer because obviously we got a lot to talk about. But hang in there with me. So what we're going to start with is the latest on the Storm Prediction Center. All right, so this is the latest, just came out just a few minutes ago. So if you notice, right here in the middle, that big old red area, well, that's right center dead is Oklahoma City. Okay, so we're going to be kind of in the center sweet spot of the moderate risk of severe storms. So the moderate risk of severe storms, of course, indicates basically a higher probability. Now, if we go to the tornado outlay, the Storm Prediction Center has a hatched area that extends from really a good chunk of Missouri through northeast Oklahoma and then now down to Oklahoma City and even southern parts of the state, just about to the Red River. And you have other shadings down to Texas and way up northeast. So it's a fairly large storm system affecting a lot of folks. Now the wind, same kind of deal. You have that sweet spot, northeast Oklahoma up north and east. Doesn't mean you won't see wind outside of that. It's just a probability. In other words, the amount of square miles versus the number of storms and reports. Hail, if you look at this category here, sweet bullseye right over central Oklahoma. up into Tulsa and Oklahoma City. So that's where you're going to have your big hailstones. So if we were to skip down here and read the discussion from the Storm Prediction Center, their highlights are very large hail, 2 to 3 inches in diameter, wind gusts up around 80 miles per hour, a few tornadoes, maybe even up to a strength of an EF2 expected this afternoon into tonight from North Texas through Oklahoma into the lower Ohio River Valley. And if you were to scroll down here to our part for Oklahoma and North Texas, it talks about how we've got a little bit of a weak cap in place, which is normal. We have a lot of storm developing late afternoon when we start to get more of that upper level forcing and mid-level forcing from the west. We have some shear that increases during the evening hours. Kind of a sweet spot here in central Oklahoma that if we get any storm in that environment, they will have a better potential for producing a tornado. So initially, early on, that might be a limiting factor because the lowest level winds won't be quite that strong. However, we'll look at some data and we'll see what the latest is with that. So again, the short view here, this was before it was updated from the Storm Prediction Center. There will be a moderate red ring drawn here over the central part of Oklahoma City and north and east, but also highlights the baseball size hail and 80-mile-per-hour winds. And also this graphic here for the tornado potential is also going to be a little bit different. I don't have to be updated, and my connection's slow, so it was on there a minute ago, and of course I lost it, but maybe it'll update if I hit refresh. For Tulsa, let's see, they had, of course, most of Oklahoma already in kind of an enhanced area, and they'll have to update this graphic too to put the moderate risk on there. So let's look at a little bit of the data. So there's a couple of sites I like. Let me see if Norman did theirs yet. Okay, so Norman just updated theirs, so there you go. They went from low to medium on the tornado threat, and the baseball size to softball size. So that's the magnitude that's changed in the last 3 hours. So you're wondering, why did everything change so much, right? Well, that's because you have to look at the latest high-resolution short-term data for your best guidance. And the guidance was very murky yesterday and last night and even early this morning before the newer runs come in. And then now that they're in, it's a lot more clear as far as the magnitude goes. Now, the newest tech model is still coming in. I don't know if it's gone in for the whole day. Let's take a look. It's out to 7 hours. Okay, we'll have to come back to that. But it's a fairly good model that I like to use for severe weather. So what we're going to do instead right now is focus on the experimental model, which is our brand new model that we're supposed to be using in the future. All right, it's called the RRFS. It's supposed to be the best that we have. All right, and I'm only going to show this because I want to show some of the key features that are important for today. So if you notice these little winds here, these little vector barbs, they're out of the southeast, okay? Up here, they're out of the north. So you see that? So right here, you have your confluence zone, which is a cold front, right? Now down here, you have an ill-defined dry line. How can you tell? Because you have a southwest wind right here. Now this is a dew point map, so it shows the difference in moisture and where the dry air is. So we see all these areas in blue and purple. That's some deep low-level moisture. So we have 70 dew points coming back in Oklahoma. Now remember, if you ever hear me, I always talk about you need 60s for tornadoes, usually around this part of the country. Well, we're going to have 60s and some 70s coming in. So what we're going to look for, and if you remember my post Easter morning, I'd mentioned there was 2 areas I was looking at for tornadogenesis. One was in southern Oklahoma, and one was in north central Oklahoma along a triple point that would move east toward Tulsa. So this is what I was looking at in that data yesterday. So you see these little wind barbs here, how they kind of come into this little circle point. This is what we call a little meso-low. Also can be called a triple point, where you have winds converge at the surface. And when that happens, your shear profile looks like the following. You have a southeast wind that turns with height as you go up in the atmosphere. So that gives you a nice shear profile, right? So that gives you a nice curved photograph, and it gives you potential for a tornado. Plus, you also have the shear values go up with numbers, so at 148 meters squared per second squared, and the Cape values are around 2,000. You have very little cap. That CIN-H number, usually when it's below 25 for surface, your cap is easily breakable. So we have a very weak cap in place, and that's the shear profile for any storms and convergence in this area. So we'll likely see a storm initiate here first. It's usually how that works. And then as this low kind of travels northeast and moves east, and the storm along in that environment with it, that means north central Oklahoma will be a favorable area for tornadoes. All right, the other one down here you have a similar situation. You have these winds that come in out of the south, and they curve right here through Lawton out of the southeast. So while that's happening, is because you have the southwest wind right here. This little zone here is called a dry line bulge that's trying to form. Now, we don't have enough dry air mixing down the surface in this model output, but we do have a ton of convergence, so it can work the same way. But what it does is it backs the winds. When you backs the winds, same scenario as if you had up north with the mesolow, little surface low. I picked the wrong spot, looks like on this map, which can happen because it gets ugly once you get storms to develop. And on this map, you can't see the storms. Let me go over here. I'll pick a different spot and see if that's better. Okay, so this one's a little bit better. All right, so you have a nice curved photograph, a lot of shear involved. You have a south wind that goes up to a southwest to southwest breeze aloft. And this is still early in the game. I'm picking, I think, at 5 o'clock. And you can see the tornado potential down here on the right, this little line, yellow line. This is an EF2 in the whisker plot, right in the middle of the average. And believe it or not, it is even in the EF3. So even though the Storm Prediction Center did highlight EF2, the data suggests it might be possible to get EF3 today on the strength scale. Now again, if you're in a well-built home, that's fine. You don't have a problem. Just seek a shelter. Just seek shelter. Your home will still stand. Okay, so let's take a look at. Let's switch gears now, because what's going to happen now is we're going to go to the model output as far as what this looks like. So let me back up here to a 4 o'clock. All right, so 4 o'clock. We don't have much going, right? We're going to go the next scan over, and then boom. You see how this little storm bubbled up? That's very close to that triple point I talked about. And here's another cluster of storms on the bulge of the dry line. So that's usually, or typically should be, how this event starts. It's not guaranteed, but that should be how it goes just based off the surface parameters. But look what happens at 6 o'clock. So we have those supercells going up in northern Oklahoma through Enid, etc. And then you have down here in Oklahoma City, points to the south and west. Now you see this little trail, this guy right here? Now what this indicates is a left-moving supercell. Now, left-moving supercell produces some big hail, but it's very hard to get a tornado out of a left-moving supercell. It can happen, but it's very difficult. So if you have a left-moving cell, your odds are better at not seeing a tornado than you do have a right-moving supercell, which is what these guys will do. So it could be possible this afternoon that we have a pretty nasty supercell go through at least the western sides of the metro that may not produce a tornado, whereas maybe these guys down here do, and maybe these guys up here do because of the wind field I talked about and what we have to work with. If I go on through 7 o'clock, you can see how quickly they move east of Oklahoma City. And all these little tracks here in this little red shaded area, these are what we call helicity tracks. So helicity tracks indicates potential for some large hail, damaging wind, and yes, a tornado if the other parameters are there for it. And so we have that here too, and some of these are pretty long, which means these thunderstorms will rotate for a long period of time. And a long rotating severe supercell thunderstorm are the kinds that produce tornadoes. All right, so that will move on off to the Tulsa area here at 8 o'clock. You can see some new development back here, by the way, around 8 o'clock on the west side of the metro. Now, this is going to be problematic for two reasons. One, these departing storms is going to cause quite a bit of subsidence around the greater Oklahoma City metro area. So as these storms move in, they might start off pretty vicious at first, but they're going to quickly diminish. So watch what happens. Let me go back. Okay, you see how this storm is kind of in a two-pronged core, 2 tracks? And the next one over, right here, okay, put that, it's kind of hard to do this one-handed. The bottom core disappears and the top core hangs on. So it's coming into stable air is what that indicates. So although we might have a secondary round this evening, there still will probably be some hail with it, but I think the tornado threat will be over. In other words, I think that's going to be shifting further out to the east at that point in time. So that is our highest resolution data that indicates that. And we have some other things in the atmosphere. So for example, when you're looking at the 500 millibar jet streak, this is 60 to 75, 80 knots here moving through central Oklahoma. So we call, in this particular mid-levels of the atmosphere, we call that basically a nice punch of mid-level air that can really help to enhance severe thunderstorm progress, development, the height, the strength, etc. When you look at the 850 millibar, which kind of represents a low-level jet, what I want to show you is at the onset of this data, it's actually fairly weak, which is good when you have those supercells starting early, right? Because you obviously don't want a bunch of nasty thunderstorms with tornadoes going up when you first start it. So let me just click one image because this is taking a long time to load. So let's see, this is the afternoon. So this is about 4 o'clock. Now, if you notice, the strength of the winds are down here in Texas. So all this stuff down here is 30, 40 knots. Here in Oklahoma, we don't have a lot of wind at the initial onset. Now, as we go into the 5 o'clock time frame, you'll notice that these winds down here in northwest Texas are starting to approach the border. So now let's go back to 6 o'clock. And what's important here is that we get into the evening, this is when the low-level jet kicks in. And the low-level jet is just basically a lot of wind that can help to speed up the intensity of these thunderstorms and help them rotate a little bit better. So now in this particular case, we've got winds now in excess of 40, 50, maybe 60 knots starting to move in. So any storms in this environment this time around 6 o'clock is going to tap into this. So it's kind of like a coming in at the right place, right time. After you get the storms formed out west, they start to move into central Oklahoma. At the same time, you have a low-level jet kick in, and you have these enhanced speed shear zones. So what that really should mean is that you do have an enhanced development of tornado genesis across the greater central Oklahoma region, which includes Oklahoma City Metro. And that is why the Storm Prediction Center then upgraded us to a moderate. So it's all about the wind. It's all about the speed of the wind, the direction of the wind. And we call that wind shear. So that's kind of the highlights, the important takeaways for this particular event. Now, I can tell you there are other models that have different outputs and the different start times, and some aren't nearly as robust as others. Like here's an example, kind of similar we looked at. One starts there in north central, another group down there in southwest, and then it expands and new development down to the south. But look how it completely clears Oklahoma City. You see how it missed us? We had this cluster to the north and this cluster to the south. And believe it or not, that can happen. So I don't want to tell you it's a guarantee. We're going to see a nasty supercell in Oklahoma City because it could easily split the difference. When you have two sections that form, you have to have sinking air somewhere. What goes up must come down. So this cluster of storms in southern Oklahoma could create subsidence on the backside that ends up sinking air in Oklahoma City, and it kills off development of these guys up here that tries to develop southwest. So in other words, we could be in a sweet spot where we don't see anything. Now, is that guaranteed? No, but neither is the other end of the solution. And that's the issue with this. If you get too bogged down in the minutia of trying to be perfect at 100%, you're going to lose the big picture and you lose the message and the take home, right? And we don't want to do that here. So I'm just going to let you know that there are different ways and different sources of data to try to come up with a solution of a forecast of what's going to happen. So we go through the WRF model here from Texas Tech. I will show as we head into the 5 o'clock hour down here across far southern Oklahoma and North Texas, there's that first cluster starting to go. And if you look at this little guy right up here to the north and west of there, this guy right here is our guy that's developing along that triple point I talked about. So even though I've looked at a couple of different model solutions, the take home is the same. Two favorite areas, here, and then what happens in between, we're going to see as things develop. So that was basically the big picture. That's what I want to tell you. I want to give you just a little update on the insides as to what's happening, what the Storm Prediction Center is seeing and what they think. So the bottom line, it's a situation to where we're in a favorable area of storms today, anytime after 3 o'clock. If you live in basically the eastern 2/3 of Oklahoma roughly, there will be some hail, big hail at that in some cases, damaging wind up to 80 miles per hour, and yeah, we're going to have a few tornadoes around. Could be on the strong side, EF2, EF3. Remember, it's always the lowest floor, away from all outside walls and windows to protect yourself. If you have a well-built home, well-structured home, EF2, EF3, believe it or not, it will hold up with that. There'll be a lot of damage to it, especially on the EF3, but you'll be fine if you're in the center part of the home, away from all outside walls and windows. So keep that in mind. It's not a time to panic or anything. The last thing I want to tell you is make sure you use my weather app. It's called AT's Weather to Go. You can find it on Apple and Google Play. You don't have to use it all year if you don't want. I do prefer you use it though during the spring because it's a proprietary app development that predicts tornadoes before they occur, that track right at your location. In other words, GPS and or your address that you can punch in. And you can punch in your address, your parents, grandparents, your kids. You got many options you can put in. That way, if the tornado heads directly for that spot, then you'll get warned. So it's a preventative over-warning you. So you can get two different types of warnings, for example. You can get a tornado warning, right? Let's just say you're in Oklahoma City. There's a tornado warning for Oklahoma City. Okay, Oklahoma City's pretty big. Where do you live in Oklahoma City? Well, maybe you're from the far northern outskirts. Maybe you're close to the Edmond area. Maybe you're on the Kilpatrick Turnpike or something in Rockwell, somewhere right around there, right? So if a tornado warning is for the whole city, do you need to take shelter in that case? No, you don't. But how would you know that? Well, you wouldn't unless you have kind of like an app like mine. But basically what it does is it streamlines that specific track of the tornado itself with a little wiggle room, you know, a couple miles, and then it puts you in that immediate path of the track, and then it'll alert you with the twisting storm alert. So you'll have a couple of warnings. One will say dangerous storm approaching, which means it could have large hail, damaging winds, maybe a tornado. But as the tornado parameters increase, it'll say twisting storm alert, which means tornado alert. You know, it's a fancy way of saying tornado. But that's going to be moving into your direction. If so, you can get up to 15 to 20 minutes of lead time for that. All right, that's extra time to seek shelter, prepare, get your kids, family, pets, all that stuff together. So I advise you to use that. I will broadcast later this evening. But I'm probably going to miss the beginning because of the situation I'm in right now. I can't help it. But I will come on as soon as I can. So prior to that, use the app. If you need to, use your NOAA weather radio. You can watch the guys on TV. If they work you up, press the mute button and just look at the pictures and the drawings and the map, etc. But either say, just be safe. Tell your friends and family who aren't paying attention about the weather today that today is one of those days we have to deal with some severe storms. Well, guys, appreciate all your likes, your shares. Pass this video around. Your stars today for lunch, your gifts, donations, follow me, all that kind of stuff. So again, if you're all the way down to Texas, to Oklahoma, to Missouri, Arkansas, Illinois, etc., you're going to have to deal with some storms today. Okay? Guys, be safe, be good, and I will see you a little bit later. Okay, take care.